Okay, calculus. Let's finish off this integration by parts. This is actually pretty quick and short, and so is your assignment, although there are two parts. So our first example is example 5. So this coincides with the textbook example 5, where they do the integration of secant cubed. The first little step there is kind of a neat little step. You might want to check that out. The overlying thing that you have to do in these two problems are similar, even though they look quite different. So let's go ahead and bring in the problem. And since we have a product, we are going to have to do integration by parts. So let's pick out our parts. U is e to the 2x, and then dv will be sine dx, just splitting the product right where it seems normal. And the derivative of e to the 2x is e to the 2x times the derivative of 2x. And the integral of sine of x, of course, is negative cosine of x. So going ahead, substituting in u times v minus the integral of v times du. So minus a negative makes that plus. So doesn't look like we got very far, but that's okay. Looks like we are going to have to do integration by parts again. That's okay. We'll do that. So another u, another dv. I do like to keep the 2 with the e to the 2x, just so I don't have to have a 2 on the outside. Anyway, so go ahead and do the derivative of that, which you've already figured out. It's just twice that. And then the integral of cosine is sine. And so we'll go ahead and substitute in u times v minus the integral of v times du. There we go. Kind of simplify that out a little bit. Looks like we are just going around and around in circles. We're ending up with a sine of x just like we had before. E to the 2x sine of x, e to the 2x sine of x. We're not making any progress whatsoever. Or are we? Well, let's think about this. If you just kind of back off of all these symbols, you might realize that we just have a pre-algebra math problem here. These are like terms. Over here, I have 1 e to the 2x sine of x dx. And on this side, I have minus 4 e to the 2x sine of dx. So that's how we're going to treat it. We're going to add 4 of those to both sides and then simplify. So you end up with 5 e to the 2x sine of x dx. And on this side, they all cancel off. So there we are, almost done. We just need to divide by 5, and don't forget that constant of integration. That's it. I think that is just such a slick little problem that it looks so complicated, and then it actually isn't that bad. Let's do one more problem. This will be a differential equation problems. We haven't done very many of these. You do these the only way that we know how, which is to combine like variables. That is, this is separation of variables. So every term that has a y in it needs to be on one side of the equation, and every term that has an x on it needs to be on the other side. So it looks like we're just going to cross multiply, and then we will do an integral on both sides. And that is where the integration by parts come in, not in how you solve it, but in the fact that we're going to have to do integration by parts to do the integral of arc cosine of 3x. So u will be the arc cosine of 3x, because I know how to do the derivative of it. I don't remember what the antiderivative is, so it's going to have to be the u part, and then dv will just be the dx. Derivative of arc cosine is, well, let's see, 1 over, should say negative 1 over the square root of 1 minus u squared times the derivative of u. And so u would be the 3x, and the derivative of that is 3. And then, of course, the antiderivative of v, dv, will be x. Substitute all those good things in. Also did the antiderivative over here, so did my integral to get y cubed over 3. And then on this side, u times v minus the negative. Now, this is going to take a little bit more work, so I'm going to need a clean page. Well, here we are with our blank page, and bring our problem back to us. So we are going to do a u substitution, where u is the stuff inside the square root, the complicated part there. And then our derivative of u would be 2 times the negative 9, negative 18x dx. I don't have a negative 18x dx, I have a 3x dx. But if I divide negative 18 by negative 6, you get the 3x dx. So that's what we'll do. Go ahead and substitute in. So keep the left side. We are doing an equation, so we need to work both sides. And then we are doing a change of variable. So I went ahead and changed my variable over to u. And then do the antiderivative of that part. So we still bring all of this down. And then that is u to the negative 1/2 plus 2/2 is positive 1/2. So we get the square root of u times the reciprocal of 1/2. And then, of course, u was 1 minus x squared. And don't forget your constant of integration. Oh, but we're not done. There was an initial value. Let's go ahead and use that initial value. I did go ahead and multiply off by 3 just to kind of simplify it. And then we'll go ahead and go back to our initial value, which was when x is 0, y will equal 1. So we will take our equation that we just figured out and substitute those in and simplify it. 0, 3 times 0 is 0, so all of that is 0. And then the square root of 1 is 1. So we have minus the square root of 1. So add 1 to both sides, you get c equals 2. And you just go back to your original equation, replace the c with the 2, and there you are. Bob's your uncle. You got her all done. That's it. That's all there is. We do have an assignment to this. There are 2 parts, an offline part. The offline part has 2 problems. There's only 2 problems. It kind of looks complicated. It is a worksheet. I'll go ahead and pull that up here. We got a link to it right here. Let's go ahead and pull that up. Okay, this is the reduction formula worksheet. This looks like a really complicated problem. This is kind of a neat little trick right here to do sine to the power of n. We split it into sine to the n minus 1 times sine. Those are equal. That is correct, because you add the exponents, you get back to that. Anyway, this is so you can do integration by parts. So this is called a reduction formula because you're starting out with the sine of n and you are ending with a sign that has a lower power. So if you have powers on the sine of n, you can keep going through this formula and it will reduce the power until you finally get down to one that you can just do the integral of. The only problem is that somewhere in all of those symbols is a mistake. And your task is to figure out what the mistake is, correct it, so that you get the correct formula. And then problem 2 is to use that formula on the sine of power 4. I do believe that you're going to have to use it twice, because you go from sine of power 4 down to sine squared, and then go from sine squared down to 1, basically sine to the power of 0. Okay, and then the second part is going to be online, 7.2 assignment 2 in WebAssign. Again, there are only 2 problems, and they are both differential equation problems. Neither one of them are particularly difficult. There's just only 2 of them. I figure that's enough for right now. Thank you very much. Get your homework done, wash your hands, stay healthy, and we'll get through this.